algebraic proofs, or essentially proving some algebra equations true. Now, we're going to start looking at this one first, the properties of equality, and then we'll move on to actually using those properties of equality. First of all, first and foremost, I'm not going to write this word out every single time because it's way too much to write. So I'm going to write out POE, which stands for property of equality, because it's just too much to write out every time. Okay, so properties of equality. Equality. What does equal mean? Or what does equality mean? What does the word equality mean? Equal. It means that they're the same, right? So properties of equality have to do with keeping something the same on both sides of the equation. So if you look at our warm-up question over there, right, we subtracted 7x on both sides of the equation. That's a property of equality. So if you do it on both sides of an equation, it's called a property of equality. So I'm going to come write that up over here. You're going to do the same thing on both sides of the equal sign. That's the only type of, that's what a property of equality means. So I'm going to say, do the same step, I guess, on both sides of the equal sign. Okay, so that means if you're going to subtract on both sides of the equation, that's a subtraction property of equality. If you divide on both sides, that's a property of equality. Doing the same thing on both sides of the equal sign. Now, these first four are super simple, right? They're talking about if you add on both sides of the equation, that's the addition property. If you subtract on both sides of the equation, that's the subtraction property. And so on and so forth for multiplication and division, right? So if you do that on both sides of the equation, you've already done those properties, right? That's all that those first four are, and those are the ones that we use the most. Now, the reflexive property just says that if I at the very end get like the number 1 equals 1, that's a property. It says that something is equal to itself. The only other one, we're not really going to worry about the transitive one, but symmetric property is talking about symmetry. It's being the same on both sides. So like our equation up there that we did for our warm-up, we got the equation 15 equals x. I can rewrite that as x equals 15. They can just trade places. That's the symmetric property, okay, for x equals 15. They both mean the same thing. It doesn't matter how I write them. That's the symmetric property. And then the last one there is the substitution property. So again, if you take something and plug it in for something else, right? We take our numbers, we plug it in for x. That's the substitution property. So we're going to focus on these ones first. And what we're going to do is we're going to use one of these to fill out our algebraic proofs that you see here. So keep that out, but now we're going to go over here to this problem where it says algebraic proofs. So when you see a proof, first of all, what does the word proof mean? Evidence. It's evidence, exactly. So think about it like this. Pretend you're a lawyer, okay? And you want to say, you guys ever watched like Law and Order SVU? No? Oh my gosh, you guys are missing out on life. It's my favorite show in the world. Okay, anyway. So you're a lawyer, right? And you want to say, my client is innocent. Well, you can't just walk up there and go, my client's innocent, and that's it. Right? You need some kind of evidence for it. So you have to say, okay, my client was like at this place at this time, and he knows this person, and he has this alibi, right? You're giving reasons for your statement. We do the same thing in math. We make a statement, we have to give a reason behind it, why we're doing what we're doing, right? Because you can't just do something and say, oh, that just works. You have to tell me why it works. That's what a proof is. It's just saying why the algebra works or why the equation works. That's all that it is. So on the left side here, these are called your statements. I know it's really small, sorry. Those are called your statements. On the right side, these are your reasons. So I give you the statements and you have to tell me, okay, what property works? Why is it true? Okay, you're just giving me the reason for each one. So the first thing you're always going to see is I'm going to give you an equation, and like 99% of the time it's going to be given to you because I have to give you some kind of information to start. Okay, so the first step, here's my equation, it's given to you. Now I have to decide if I go from, excuse me, this step to this step, what changes were made. So if I'm going from here to here, what changes do you see in that equation? Give me something that changes between the two. Sydney, go ahead.
Multiply by 3.
Where? On the left side, good. Okay, so here's multiply by 3 on the left, good. And on the right, good. You've multiplied both sides by 3. And because you did it on both sides of the equation, it's a property of equality. Hey, guess which property you just used? You used the multiplication property of equality. You multiplied on both sides. Perfect. So my first reason is the multiplication. And again, there's not enough space to write property of equality, but we're going to put POE. You do have to put POE because you're showing it's happening on both sides of the equation. So you have to state that. Okay, beautiful. Now, to get from this step A to this step B, what's happening? Elijah, what do you think? Distributing what?
We put into parentheses and just
Yeah, good. You're taking that 3 on the left there and you're giving it away to everything inside the parentheses. Now, did you do that on both sides or just one side? Just one side. So it's not a property of equality. It's just a regular property. What's that property called? Elijah, you just said it. It's the distributive property. And look, here's my property right down here. Distributive property, right? There you go. That's your second step. This is the distributive. And again, I'm just going to put prop because I'm writing this out. Good. Now, to get from B to C, what's changing? What did I do on both sides? Ratio?
Subtracting 2.
From where?
19 and 42.
Good. So it's on both sides. So because you subtracted on both sides, it's the subtraction property of equality. Because you're doing it on both sides. Okay. Last step. Okay, I can't do that. Here we go. From here to here. What do I have to do? Kiki? Division what? Is it just a property or is it a property of equality? Why? Are you doing it on one side or both sides? Both sides. So if you do it on both sides of the equation, it's a property of equality. So this is the division property of equality. And I will tell you, like 99% of the time, your last step is always going to be the division property because you're usually dividing. And that's it. So I've given you the statements. You just have to fill out the reasons for each one. Questions so far? Okay, do you think you can do number 2 or do you want me to do number 2 with you? Feel ready to try one? Yes, no, Lisa? Your non-answering is not really helping me at all. Would you like me to do another one with you? Yes? Okay. Number 2. All right, again, first statement, like I said, is pretty much always going to be given to you because you can't do anything unless you know what the equation is. So to get from this step to this step, what changes? Elijah?
They distribute, they put the 2 and 2 parentheses.
Good. So you take this 2, you give it away to both sides. Are you doing it on both sides of the equation or just one?
Just one.
Just one. So it's just the distributive property. I'm going to put a P. Distributive property. Good. Okay, someone else. To get from A to B, what do you do? Subtract what?
Right?
Am I subtracting?
No, it's like you gotta divide, right?
Well, you're jumping ahead to this step. I'm saying just from here to here, what the difference is.
Oh, that was the substitution then.
So if you're looking, well, you went from 40 to 64, right?
Oh,
Yeah, so what happened here? What did I do? How did I suddenly get rid of the 24?
oh, you added.
I added it to both sides, yeah. So look, if you have to write in like Mr. Massa is doing, like a little bit of showing the math, do it. You add it on both sides, so it's the addition property of equality. It happened on both sides. And now the last step to get from B to C is what? Last step. Juan, what's the last step?
Oh, do we substitute? Or do we divide?
Which one? What do you think?
Oh, I usually divide.
Yeah, exactly. Substitute is only when, if you're taking this like x equals 32 and you plug it in for something else. Substitute means plug it in. You're not plugging anything in to go from here to here. Okay, so you're dividing both sides by 2, and since it's both sides, it's the division property of equality. Yeah, I-O-N, wow, okay. It's a tough word. Division property of equality, and you're done. How you feeling so far? Thumbs up, thumbs down, thumbs to the side. Ooh, one thumb, very helpful to me. Very helpful. Okay. Yes. Yeah. Now, what is different about number 3? You guys said what? 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 What's? Who can raise their hand and tell me what's different about number 3? It's like 10 of you just talked at the same time. What's different, Kiki? I got letters this time. Yes, I do. That makes things a little different. What else do you see that's a little different about this problem? Okay, after the letters, I got some numbers. Good. What else?
A line.
Is it a line?
Segment.
Oh, it's a segment. Those are 2 different things. This is a segment because you've got a point and a point. You got a starting point and an ending point. So this is a segment. I have friends, I would write that down next to it. A segment. Now, first thing I give you is that AB equals 50. So if I started from A and I went all the way to B, this whole thing is 50. That's the first thing I'm telling you. Second part says AC plus CB equals AB. So come up to the picture. That's saying if you add AC together with CB, you should get the whole thing, which is what? Huh? 50. Good. So if you add this piece plus this piece, you get the whole thing. Does anybody remember what that's called? Yes, you do. You're adding things together. You're adding what together? What are they? What are they? What are these? What is this one? What are these little pieces? It starts with the word segment. I feel like Rosie about to say it. What were you saying? What words did you just say?
I didn't say anything.
I thought you said something. Segment. You're doing what with the segments?
Addition.
Segment, addition, postulate. Is that bringing back any memories? Okay, lie to me, say yes, because we took notes on it. You did a whole worksheet on it. Okay. Segment, addition, postulate means you add the two small segments together, you get the whole thing. Remember, Mr. Master did it. I even walked up here, said if I take 5 steps, and then I take 10 steps, in total I take 15 steps, right? Ooh, okay.
Oh, yeah.
It's been a while. I know, it's been a full week since we've talked about that. Woo. It's tough. Woo. All right, segment, addition, postulate. Now, to get from, I don't know what that called. To get from here to here, what's happening? I'm substituting, exactly. So I'm taking the equations and I'm plugging them in. They're taking their place. So this is the substitution property. Substitution property. I'm plugging it in. Okay, now substituted it in. How do I get from, and the lettering is off, so I apologize. I just noticed that. How do I get from B to D? What should I do to get from here to here? What do you notice is happening? Where's the change? Elijah, what do you think? Yeah, you're distributing. What are you distributing?
The quantity of x plus 1.
Good. So the only thing that changes, look, the 50 stays the same, the 2x minus 2 stays the same. The only thing that changes is I take this 4 and I give it away. Now it's only on one side, so it's just the distribution property. Okay. Now, from D to C. What is happening there? Brian, what do you think? Say a little louder. Combining like terms. Good. So I'm putting all the x's together, and then I'm putting the numbers together. That is literally called combining like terms. That's a step. Combine like terms. And if that's too much for you to write, and you don't want to write that whole thing, combine like terms is exactly the same as simplifying. Simplify. Both of those mean the same thing. Combine like terms or simplify, so if you see either one, they both mean the same. All right. Now it should be really easy. How do I get from C to the other D? What do I do? Subtraction, what? Property of equality. Subtract 2 on both sides. Subtraction property. Property of equality. And then last step to get from D to E, division, POE. Good. So I don't think it's hard, but what you have to be careful of is typically when my scholars do the algebraic proofs, they always seem to forget a step. They always want to go like one ahead, and so most people always have like the last one empty. Okay, make sure you're using all the lines that I give you. I'm not giving you extra. I give you just the right amount. Okay, so make sure you're using all the lines. If you're not using all the lines, you're making a mistake somewhere. All right, that's like as hard as it gets right there.
Okay.
That's it. That's as hard as it gets. Now, take a look at 4 through 7. For number 4 through 7, you are naming the property that justifies going from the first statement to the second. So I just want to know, what is the one step that gets you from the first statement to the second statement? Okay, that's all I'm looking for. Now, number 4 is a little different. What's different about number 4? You got letters. Do you have any numbers in number 4?
No.
No. You've got no. Okay, I cannot get this. You've got no numbers. So if you have no numbers, this is called a property of congruence. So look, go back to your little half sheet. Properties of equality all have to do with equal signs, right? It's an equation. Properties of congruence are talking about angles and segments. Now, this little symbol that you see there, has anybody seen that symbol before? The equal sign with the little squiggly on top? Yeah, do you remember what it means?
Estimate.
Oh, it does not mean estimate, but good try. Why is this going? Oh my God. No, it's I'm in a text stream with my family.
Oh.
And what are they doing? Do they not have things to do? Got things to do right now. Okay, this little symbol right here means congruent. This little symbol means congruent.
Okay.
Which means same size, same shape. Same size and shape. So the reason that we have that congruent symbol is because when we're talking about an angle or we're talking about the shape of something, we're saying that the pieces are congruent. So you can have two angles that are congruent. If they're both 50 degrees, they're congruent. Okay. So now in number 4, naming the property. So here's what it says. It says XY is congruent to TZ. So the line XY, or excuse me, the segment XY is the same length as the segment TZ. To get to the second step, it says TZ is congruent to XY. What happened from the first step to the second step? What's the difference, Sebastian?
They switch places.
They switch places, exactly. So now, looking back over here, which property says they switch places? Switch places. Which one of those 3? You only got 3 choices. Symmetric, yep. So think about symmetry. It's the same on both sides, right? So the symmetric property is your answer here. It's not a property of equality because it's not happening on both sides of an equal sign. It's just a symmetric property and nothing else. Okay. Can you take 30 seconds and answer 5, 6, and 7? So I just want to know how you get from the first step to the second step. That's it. It's one step. And you're just telling me which step it is. Okay? Take 30 seconds and do those 3. Well, is it going to be properties of congruence or equality for number 7? Congruence. So you only got 3 choices. It's got to be one of those 3. Correct. You got a 33.3% repeating chance of getting it right. So that's fun. When you're done, put your pencils down so now we're ready to check them. All right, what'd you get for number 5? Distributive property, beautiful. You just put distribution, that's fine. Yep, so all you're doing is taking that 3 and giving it away to everything on the inside. It did not happen on both sides. It only happened on one side of the equation, so it's just a property and nothing else. Distributive property, good. What about number 6? What is happening in number 6?
COT.
Combining like terms. Perfect. Or you can put simplify. Both are fine. Both are fine. Okay. And then number 7. Transitive property. So the transitive property literally means if angle A is equal to angle B, right? So let's say angle A is 20 degrees and angle B is also 20 degrees. And then let's say angle B and angle C are the same. So if angle B is 20, angle C is 20, guess what? Angle A and angle C are also the same. They're all 20 degrees. Okay, that's all the transitive property means. Okay, questions, comments, concerns so far? Do you think you can flip it to the back? You've got 7 minutes till the bell rings. You're going to do those last 4 problems. Yes, babe. You want me to go back?
Yeah.
Okay.
I just have a question.
I have an answer. What's the question? That would be a good thing to have.
He did that on purpose. No.
I know, he just missed us already.
Yeah.
What is it? What is it, Sydney? What?
Okay.
What?
Bro.
So, wouldn't it be property quality for number 4?
No. So property of equality literally means an algebraic equation, right? This is not an algebra equation. This is talking about pieces of a line that are the same. And so as soon as you've got a congruent symbol, you're now talking about properties of congruence, not equality. But that's a great question. That's a good question. Okay, you're flipping on to the back. You're working on those 4 in the back. I don't think we're gonna have time to check them today, but we'll check them tomorrow. Again, you better use all of those lines up, all of them. None should be blank. Yes, ma'am.
I do this too.
Just don't forget to put property of equality when you're putting them, because that means 2 different things. Substitution, combine like terms. Yep, yeah. So just make sure you're putting that for each one. Subtraction, division, good. Distribute, subtraction, division, yep. Subtraction, division. Yep, you're good. Just make sure you put, so it can't just be property, it's property of equality, because if we're doing it on both sides, you have to make sure that you're saying it's an equality property.
Oh, no. It's not. Combine that. I'm sorry. The next one? Yeah.
Well, my parents are the I'm gonna say no.
I'm looking for my other stapler. Okay, there's a stapler going around, so you can staple that paper into your notes. I would, if I were you, only put a staple at the top of the paper so you can still flip it and see the back of it. Okay, so they're passing around some staples, a stapler, and then like I said, just put one at the top because otherwise you're not gonna be able to flip it over and see it. We will check that paper tomorrow. As you're finishing up, you need a not a calculator. Oh my gosh, you need a electronic device tomorrow. Okay. So if you have your computer, bring your computer tomorrow. If you do not have your computer, tell me and I'll print it out for you.
Yeah, give me the.
But I'm hopeful you guys have your computers by now.
We get a paper.
No, you don't want a paper because if you.
No, like a paper to fill it. You get like, you have that or no?
Oh no, go to your English teacher for that. I do not have those.
Okay.
English teacher. Okay. So tomorrow, bring your computers Your only homework tonight is to finish that paper, okay? Try them, we'll check it tomorrow. But if you did not finish the 1.2 to 1.4 practice from Friday, the Canvas practice, do that tonight. So you don't have to worry about getting it done tomorrow. Technically it closes tomorrow, but do it tonight. I'm not giving you anything else to do, okay? Do that tonight. And then tomorrow, like I said, bring in your computers. We're gonna do some 1.7 practice on the computer, okay? So bring an electronic device tomorrow. Okay, questions, comments, concerns? All right, we will check those papers tomorrow. Make sure you stapled it in. Does anybody need a stapler still? Yeah, can you just staple that back? Is there another staple somewhere? You guys know what yours? Staple it in and just put one at the top, and then we're good for today. You guys did a great job.
Which number is Wednesday, Thursday, and Friday?
Oh my gosh. So it goes by date. But Friday there should be nothing in there because that was online. Wednesday is the 25th and the 26th.
So easy.
I know, but they have.
They do what? Yeah.